Hi everybody. Hey, hope you're doing well. Let me know in the chat if you can hear me and see me and everything is all good on that end. I will just kind of let people file in slowly before we properly get started, but it's great to have you all and thank you so much for coming to our second workshop of the day. Very committed. Before we start, I just wanted to remind everybody that we have another workshop tomorrow, and that is with Talisman. So they are not a bounty provider, but they are here to give a workshop and just provide you guys with some more information and some tips about building with Polkadot. So if that's something that you are looking for, then do join that tomorrow. And we often get asked about this, so I will say now that yes, this will be recorded, but I definitely recommend giving a listen live because that way you can ask our speaker Andy some questions. We're just waiting for Andy to come in. But yes, in the meantime, I would just like to encourage everybody to give me a follow on Twitter. I'll drop that link in for you in a moment. And also to keep asking questions throughout. If you just ask them in the question tab rather than asking them on the chat, that way I can see them even when the workshop is over. And if Andy didn't get to them during his talk, we can ask them afterwards. And also, and I said this again also in the last workshop, but please do give me a follow. Give me a call rather. This like it really doesn't matter what stage you're at. It would be really wonderful to catch up with you and hear how you guys are getting on with the hack. So I would really appreciate if you booked a call at any point in the next few days. I've still got loads of availability, not tomorrow, but in the rest of the week. So yeah, do book. I would love to see my inbox full with invites. Now, hopefully I should be able to see Andy.
Hello. I hope for me the background is flipped.
Yes, all good with your background. Thank you. Yeah, I mean, I have given a little spiel already, so we're ready to hand over to you. And yeah, just go ahead, take the stage.
Okay, thanks. So, welcome everyone. Thanks for attending this call. Yes, so let's get right to it. Let me share my screen. So, let's talk about Acurast. So, Acurast is a decentralized serverless cloud. What this means is basically that, well, I'm sure all of you are familiar with the famous cloud providers like Google Cloud, AWS, and so on. And we are basically building a decentralized version of those clouds. And in this presentation, I will show you a little bit of how we want to do that. And in the end, I will also give a demo and show how exactly you can use it. So there are a couple of problems with the traditional cloud providers that we know. First of all, they're quite expensive. So we all know if you kind of buy your own server hardware, that's a lot cheaper than renting storage or like compute power in the cloud. But of course, it kind of comes at the cost of not having redundancy. The cloud is much easier, but it is still in the end quite expensive. It's also intransparent. Kind of, you don't really know where your code runs or what machines it's run on. It's also very centralized. So almost all of the big cloud providers, they are based in the US. So local laws apply. And maybe some people, they are not allowed to use it or access is restricted for some of the users if you use or deploy or host your site on some of those cloud providers. And also it's not confidential. The cloud providers, they basically have access to your code, to the secrets that you environment variables and everything that you run in the cloud. They can basically see that. So we basically set out to tackle some of those problems and try to solve them in a decentralized and permissionless way. So one thing that we realized is that there are new chips that are kind of changing the game, and those chips are basically mobile chips, or chips that are used in mobile devices. Because as we all know, our mobile phones, they're getting faster and faster every single year, and they reach a point where they're actually comparable to modern server hardware in a lot of ways. So we thought, why not use that? Why not uh, utilize those chips that everybody already has and use them to create decentralized cloud? So not only are these chips comparable in compute power in some areas, they're actually better in some areas because, as many of you may know, GPU instances, for example, in cloud, uh, in traditional cloud providers, they're quite expensive. They're actually very expensive. And I'm not even sure if many offer like machine learning specialized chips like TPUs. So if you want to do more specialized things than just general computing, that's sometimes not possible or getting very, very costly. But the mobile phones, they have this chipset integrated, and they provide a variety of different chip types in one device. So what this means is that you can actually compare the device of a quite cheap mobile phone with a very expensive hardware rack that is used in data centers. Here we have one such comparison. So we can see that for around $3,000, you get something that a mobile phone can do for $500, which is like a 6x cheaper. And if you look at the CPU mark, then that's the mobile phone actually performs better than the server rack. And as I mentioned before, there are also cheap other types of chips in the mobile phone. So depending on your specific use case, it may actually be a lot more than what we see here. And then another metric that is very important is the kind of the cost per watt, because in the end, energy is something that is very important, and all computing takes energy. And if we take a look at the energy consumption, then it's like a 50x difference when you compare the mobile phones with the big server racks. Now, there's also another cool use case with this, which is basically that you can upcycle old devices. So you can actually get old destroyed phones that where maybe the screen is broken or some buttons aren't working. You can get them for very cheap because usually they're not really needed anymore, or people can't use them as mobile phones anymore. But if you just want to run code on it and use the compute power of those devices, then they're perfectly fine. So you can sometimes get very, very good prices, which brings down the kind of the cost of running such a network down even more. So people have started to realize this, that you can buy broken phones and participate as processors in our network, and they are starting to build farms. So as you can see here, people there using broken phones. In one of the pictures, you can see that the devices, they don't even have displays anymore. So it's basically just one display that works, and if you have to debug something, then you just plug in the display that in the device where you have to. But other than that, you just leave the device running, and you don't really have to touch it again while after you have set it up. Yeah, so if we kind of summarize all of that, this means that if we want to rent an instance on Google Cloud, we pay around $370 per month, whereas we can get around the same performance on a mobile phone with Acurast for about $10 per month. So that's a huge, huge cost difference. Now, until now, I basically just talked about the, let's call it the vision, or how we envision the system to work, but we didn't really talk about the specifics because, of course, there's a lot more to it than just having mobile phones and people who want to run code. So what we have is we basically built a system where devices, we call them processors, can join the network. They can advertise that they are available to do work. And on the other side, we have consumers, which can post jobs, which is basically code that they want to run on those processors. And then we have a matching engine that has a reputation system and other parameters that matches the right job with the right processor. And after the matching is done, the processor will acknowledge the job. And once the job has been executed, then the reward will be paid out. Because of course, the idea is that the processors, the people that provide the compute power, they will be rewarded by for running code and the jobs, and the people who want to run the jobs, they are the ones paying for the execution. So we have a couple of bounties for those of you that are interested. So let's look at the first one. The first one is the no-code Oracle onboarding experience. So basically what we're looking for there is we want to you guys to develop a platform or a website where users with no to little coding experience can basically select the APIs where they want to have, for example, price feeds from or other data, and they can kind of plug and play style choose where the data should come from, which APIs, the interval in which the results should be posted on chain, and so on. So they can deploy their own oracles without having any coding experience. So that's what we're looking for in the first bounty. And then in the second one, it's basically kind of just an open challenge. We're just looking for the best application that uses the Acurast Compute, kind of the cloud that we built. Yeah, so that's already it from the kind of the theoretical side. Now let's jump right into the demo. So when you start to use Acurast, then you will first go to the console. What this means is that the console is basically where you can either register processors if you have devices, or where you can run code. So first, what we have to do is log in. You can do that with our normal Polkadot.js or Talisman. So I will use Talisman here. And now I'm connected. If you have devices connected, then you will see those devices here. You can actually see that the version of the kind of the processor version that is running on it. You can see your reputation here. Well, I guess that processor didn't do so well because it went down to 0. And you can also see how many jobs are running on it. At the moment, we incentivize people to run processors. So that's why if you set up such a processor, then you will get those Kaku tokens as a reward. And the process of onboarding a new device is actually quite straightforward. So because the Android system allows has a feature called managed, or I'm not sure what the exact name is, but it's like to enroll a device as in a managed environment, meaning that someone else will completely take over control of that phone. So how you do that is you take a phone and you completely wipe it, factory reset it, and then you click on the launch screen, you click a couple of times until the QR code reader shows up, and then you can click here, add new device. Actually, we have to sign a message here to prove that we are the owners of the manager account, and then you can scan this QR code and the device will automatically set itself up. So it will download the APK it needs to run and do everything for you, and the device will show up in the list here. And is basically then ready to run jobs and earn rewards. You can then also, for like advanced users, you can also set some parameters like the base fee per execution and the fee for storage and so on. But those are more advanced things that we won't get into right now. So this, what I showed you right now, that was basically the part of the processor. If you have a device and you want to be part of the system to provide compute power. Now let's take a look. Now let's take a look at the side of the developer if you want to create a job. So what you do here is you go here to create jobs, and then you can select the protocol, or basically the target chain where your Oracle or your code wants to submit the data on-chain. These are basically just templates. So we provided a couple of examples. So for example, if we take Ethereum, we can go to the testnet here. And then we have, by default, we have this price feed example. So as we can see here, we basically have some JavaScript code where we have a destination. So this is where the contract address where the result will be posted. And then we have some very simple code where we basically fetch the price from an API. We take the price, we manipulate it a little bit, we encode it in the right format, and then we call this fulfill method with an Ethereum node on that destination and post the payload along with some fee information. And yeah, I mean, I think that code is quite easy to understand. And now what you can do with this code is you basically post it to the network as a job, and then you wait for someone to pick it up, for a processor to say, okay, this is a job that I'm willing to execute, and then he will do that. Okay, good. So now what I prepared, and I have to say that there were some changes, some last minute changes, and there is some problem with the format, with the encoding. And before the demo, I sadly didn't get it to work. So probably will not be able to actually see it, how it really, the contract call is successful on chain, but we will see how it fails. So if the encoding was right, then the execution would actually also work, and the price would be updated. Or in this case, we actually post a random number. So to get started here, we can go to our docs under docs.acurast.com. And in this case, we look at the EVM smart contract example. So here we have a very simple contract. So we have a processor. That's basically the one, let's call it the allow list, which processor or which Ethereum address is allowed to actually update the randomness in this contract. Because of course, you always have to think about the security, because if you have a contract, an Oracle contract, then obviously only the processors that you are controlling should be able to actually update the price, and not everyone, because then people could manipulate the price. So in this case, that's done on in the constructor. You could, of course, also have another method that says that has a list of allowed processors, and then you can update them on the fly and remove them and so on. But this is a very bare bones example. Then we have two other methods. One where we actually post the entropy on chain. So the job itself, the device will create or collect random entropy, and then it will call this method and post that random entropy on chain. And then we have one that consumes it. So that can be used by another smart contract. So if we go here to Remix, then I have added this code. I actually adjusted it a little bit, simply for simplicity reasons. I removed the whitelist or the allow list. So at the moment, everybody is allowed to update the entropy, which is of course not good in a production environment, but for testing purposes that should work. So yeah, then I have already deployed this contract, and here, where is it? Here we have the contract address. So now we can go here, we can take the Ethereum verifiable random number example, and we can put in the contract address of the contract that I've just deployed before. And then here we have some methods that are specific to kind of our context here. So this generate secure random hex, that's an instruction that will be executed by the processor itself and will give you secure random number. And then we have to encode it. And then, as we saw before, we basically send it on chain. So we can basically now take this code and we can actually post that as a job on chain. So to do that, we can use either a public processor, so any processor that is available. We can also use a personal processor, so that would be the ones that I have set up, or we can use a specific one. So in this case, let's just use a public processor. And then we have some, we can define when this code or this job is being executed. So we have the option of a one-time execution, which means the code will be kind of immediately as the start time is reached, it will be executed once and then it's over. Or we can set up an interval where we say, okay, so let's start in like 6 minutes and then let's go for an hour and we do it every 5 minutes. So then there will be 12 executions in total over the course of an hour. Down here, we have the duration in milliseconds. So that's like you can set the limit of how long this job is going to last because it has an API call. Maybe we give it like 2 seconds in case there's some latency involved. We can set environment variables. So that's actually another very cool feature, but I think I'll talk about this a little later because it's kind of its own topic. And then down here, we can say how many processes we want to run it on, the reputation that we want, and here what we are willing to pay. So here, because we are on the canary net, I just set a very low value. And then that's basically it. So now I can say publish job. Okay, so that's a good start. Oops. Yeah, of course, I need to set the next full hour. So the start time was in the past. So now, trying again. And now we, of course, have to sign this transaction, post it on chain. I think I didn't mention that before. So we have our own parachain, which is basically responsible for doing the orchestration and the matching. So everything that happens, like the payouts, the jobs, the processor, like there is a heartbeat, meaning that every 15 minutes, the processor has to kind of verify that it's still online, that it's still there to do, ready to do work, to be in the set of available processors that can be selected. So all of this is on chain, but the whole Acurast system is actually completely chain agnostic. So it doesn't really matter which chain you want to post to. It can be Polkadot, Kusama, it can be Moonbeam, Ethereum, Polygon, could even be something like Tezos. There are many different options. So it's basically just the orchestration is done on our own chain, and the rest is completely chain agnostic. So what we can see here is that the job has been registered on chain. So we could check that out on the block explorer, and that we can also see that the processor or the job has been matched to a processor. And now we can see that the processor that was assigned actually acknowledged this job. So now we can go here to the job details. We can see again the details of when it should be running and how many times and so on. So now one thing that we have to do right now is we have to actually send funds to this specific processor, because we now set up a job and it was assigned to a processor to run it, and in the end basically post it on chain. But to post it on chain, it of course needs funds on the chain that it's going to post the result to, in this case the early testnet. So I have to, here, this is already pre-selected, I select the early network, and it gives me the address of this processor. So that's this one. And Now I can go to my MetaMask or Talisman, and I can send a little bit of balance to this processor. What this will do is that once the job is completed, or once the execution is completed, then it actually has funds to post the result on chain. So as you can see in the description here, so we're working on some. We do have some what we call level 2 integrations, where this is no longer necessary, where basically the system does that for the user, for the developer. But in this case, that's something that we have to do manually. Okay, so now it's basically just oh, it's time is already almost there. So as soon as we hit 3 p.m., it will actually run this execution once and post the result on chain. Now, as I mentioned before, because the formatting is probably incorrect, it will most likely not work. But in theory, if we set up our script correctly, that would be the moment where then we would have the 5-minute interval. In a 5-minute interval, we would have the data that we want in our Oracle contract. Yes. So I guess what we can do here is we can take a look at the processor's address and see if we can see any transaction. So we can definitely see that I sent ETH to it. And then actually, now that I think about it, it probably is not even the encoding. Also, the fee was just hard coded, and maybe I don't have enough ETH to pay the fee. So, but I hope this step, or what I've talked about until now, is kind of clear. The way how you set up a job and how kind of a job is then the result of a job is posted on chain. As we could see now in this process, I mean, I was talking the whole time, but in the end, we basically had to wait for 6 minutes for this whole process to go through. And that's kind of a cumbersome thing if you want to debug something. So we actually added a feature that we call the live code feature, which makes this a lot easier. So if we go back here to the console and we take a look at the live coding screen here, we can see that down here I have this setup live code processor. What this basically means is our processors, they support WebSockets. So you can, if you click here and say deploy live code processor, we actually replace the code that is part of a job, like the code that before posted the random number on chain. We changed it to actually run a WebSocket script that basically waits for instructions and on demand executes them, and then sends the result back to the sender. Basically, it does an eval and sends the result back. So this makes it a lot easier to debug the whole thing, because you have basically immediate response and you can see the error messages and so on. So in this case, now I would basically, if that was my first time, I would go through the process. I will set up this code on one of the processors and then add the public key of that processor here to the list. But I've already done that, so I have one processor active as a live coder. So let's see if that one is still active. And we can basically just now put in any kind of code, JavaScript code that we want. And if all goes well, then we can see that basically this code here was encoded and it was sent to the processor that is running the WebSocket script. Then the processor is executing the code and sending us the result back. So this is a very simple example, of course, but we can now also run the examples that we have ran before and hopefully get some more meaningful output. So I have to get the contract address again here. Then let's go back here. Maybe just quickly, if we go here and refresh the page, we should actually see how, so we do not, but it should actually count up the number of executions. Maybe it's because the calls they're actually failing, so it doesn't count up the number of successful executions. But let's check again afterwards. So, and here we paste in the code, and then we click here and see what happens. And probably it will tell us something about the fee being too high. Okay, so if that doesn't work, let's quickly refresh. And actually we don't. So let's try that again. Okay, so now it's entropy not defined. Yeah, so it's called payload. Now this success undefined, that's just kind of an internal functionality. We can just ignore this. It's not related to this succeeded. So what we can see, it's logging this failed here because we have insufficient funds to pay for the fee. So I mean, this is of course not the way to do it in production, but I'll just now kind of manually change the fee until hopefully it works, and it already does. So now we can see the script that we have just written, copy pasted, that was successfully executed and was sent on chain. And now we can inspect the status. So let's go here and see what happened. And as I mentioned before, this will probably have failed, but I'm sure you can see how that this is supposed to work if the encoding was correct. Okay, so let's give it a little time. So maybe as we wait for the result here to come in, I can actually quickly talk about the environment variables that I briefly mentioned before. So one of the cool things that are possible with Acurast is actually that you can have confidential computing as well. What this means is that usually everything that happens in the blockchain, like in the blockchain world, is usually public because you have, I mean, everything has to be on chain to be kind of reproducible. But sometimes maybe you have data that you do not want on chain because it's like a private API key that gives access to a lot of data that you don't want public. So what you can do is when a job gets assigned to a processor, that processor generates a key pair inside its secure chip. This means that nobody is able to take out this, to get out the private key of this key pair, like under any circumstances. Not even the developer, it's like the developer of the job, not even us as the developers of the processor software. We cannot get this key out. That's like it's like secured in the chip itself. So what this allows us to do is we can actually create a code that works with with an API key, for example, that is then decrypted at runtime, and it can access a private API, and then we can do something with this data. Maybe we can aggregate it and post the result on chain, but nobody except for that specific processor that we have selected and encrypted the environment variables for is able to see the API key, and therefore nobody is able to access the private data. So I mean, one application for this could be maybe in the medical field, where I don't know, you have like an API key that gives you access to how many times you went to the doctor, or what disease you had or something, and then you can just do an API call to get some analytics about this aggregated data, put the aggregated data on chain, but nobody will ever have access to the raw underlying health data behind this API key. Yeah, so that's the cool thing about environment variables. And now let's refresh here. And yes, as expected, we can see that the call actually did fail. But basically, let's see. Yeah, I mean, the call failed, but we can see that it was sent to the destination contract address. And if it had worked, then we would be able here to kind of add, to consume that data and read it on the other side. Yeah, I mean, that's not that impressive, sadly, because it didn't, the full thing didn't work. But yeah, that's basically the idea. Okay, so I think that is mostly it from the demo side. Yes, let me think if I forgot something. Otherwise, I think we can go back to the slides. So as I mentioned, we have these two bounties. So we're happy to help anyone who has questions about the whole system, who has questions about the bounties specifically, how Acurast works, how they can get started. We're aware that currently it's quite complex to get started. It's quite difficult to understand what the different parameters mean. It's also not very verbose if there's an error. It's not sometimes clear why there is an error or what happened. So please don't hesitate to ask us, to reach out to us if you have any questions, and we're happy to help. Yeah, and the outlook for Acurast. So make sure that you join our builders program, where you can get started with Acurast and also earn some Acurast tokens. And also, if you happen to be at ETH Denver, we will also be there, so you can reach out to us and get to know us. Yeah, and that's how you can reach us. So I think that's it from the presentation, and I'd be happy to answer any questions if there are any.
Wonderful. Thank you so much for such a thorough demonstration and a really, really clear presentation of everything. And thanks for recapping the bounties. Yeah, guys, please do ask any questions that you might have. Now is your chance before you get building to ask whatever it is you want to know about the bounties. So far, we do seem to have just the one question, and it's something I think you may have covered a bit later after it was asked. But nonetheless, Mehrab asks, what kind of Polkadot services do you guys provide besides hosting?
I'm not sure. I'm not sure if I really understand the question. So it's mostly about just general code execution that can be used in a variety of ways. So oracles are like one use case, but we don't. If I understand the question correctly, we don't provide any specific tools for the Polkadot ecosystem. We just like make use of some of the tools and allow you to, well, have this secure compute engine that then posts results on chain. I'm not sure if that answers the question, but yeah, maybe if the person could clarify.
Yeah, do let us know, Mehrab, if that does not answer your question. I think that might actually be everything for our questions for today. But do get them in, guys, if you want to right now. But otherwise, I will probably say goodbye, and once again, thank you. Yeah, so our deadline is the 10th of March, and if you have any questions before then, we do have members of the Acurast team on our Discord channel, so I'm sure they'd be happy to help you out there. Yeah, so I hope you guys enjoyed it. Thank you once again to Andy, and have a lovely evening or whatever time of day that it happens to be where you are. Yeah, there's some thank yous coming in through the chat, so I think I will end this now and say goodbye. Bye, everyone.
Thanks for having me. Bye,
Thank
guys.
you for coming.